Hi there, my name is Maggie. This is our second installment of our Schaffer-Nishimura lab tour that we went on with Michael Capraro. If this is your first time here, we're touring the lab that collects the data that we analyze in our game Stall Catchers. If you didn't know, Stall Catchers is a game that we developed to help speed up Alzheimer's research, and it wouldn't be possible without people like you. In the first installment, we got to meet everyone and to see the biolab. In this installment, we'll be looking at what they call the wet lab and the surgery room. Hope you enjoy!
Okay, so this is another lab we have. This is where a lot of the magic happens. So if we come over here, I can show you. Kirsten Ash is a postdoc working with us, also on Alzheimer's. So that one is a speckle, laser speckle microscopy. It's different from two-photon microscopy. So this one we use mostly for measuring overall blood flow in the brain. It doesn't have the resolution of getting capillaries, but we can see all the major big vessels in the brain with laser speckle. And Daniel is one of the PhD students in the lab working with laser speckle in Alzheimer's disease.
So I have a question for you related to stall catchers about this. So if you get data analyzed by stall catchers back that says for this group of mice, blood flow at the capillary level, there are more stalls at the capillary level than in this group of mice, do you then use this to corroborate that to say, is the overall blood flow, is that different between the two groups or?
Yeah, we can do that. Also, two-photon imaging helps us do the same. But yeah, we can use speckle for that. Mm-hmm.
And in fact, we've used speckle in both directions. So in the very first paper we published on the stalls, there was some data using the speckle imaging to try to map how quickly blood flow speed increased after getting rid of stalls. But we've also used the speckle imaging as a screen, where that was the first level analysis of whether or not a drug that we thought might work. That was the first pass to see whether or not blood flow improved. And then we would follow that up with two-photon microscopy to assess whether it was by the mechanism of reducing stalls. So this plays a complementary role in measuring blood flow at kind of a different spatial scale than the data that goes through stall catchers.
Thanks. Yeah, that's very helpful. Yeah.
Oh, this is Anne. She's a PhD student in the lab, stall catchers.
Oh, okay.
Working on cardiac project.
Oh.
Hi. I'm sorry.
In addition to some of the brain studies, we've started looking in other organs like the heart, and it turns out that it appears that there are some similar mechanisms, like there are capillaries that are stalled in some of the heart failure models that we look at as well. So it could be a phenomenon that is important for other organs.
I'd be confident saying that a little more strongly. It is very likely that this phenomena will be important in other ischemia-sensitive organs. Heart, almost certainly. Kidney, almost certainly.
Does that mean that someday we might see capillary images and stall catchers from organs other than the brain?
Certainly possible, yeah. Or we would love to be able to provide such data, through stall catchers.
Yeah, that would be cool.
I think the main challenge is that the heart moves a lot because we are doing in vivo imaging of the heart, and the heart is beating very fast in the mouse. So we need a way to compensate for the motion of the heart. And there are some people in the lab working on how to compensate the motion inside the microscope. So making the objective actually move with the rhythm of the heart so that you can get a still image and be able to actually, see stalls. Because otherwise it just looks like a very furry image with a lot of movement.
Right, yeah, that kind of makes sense. Kind of like if you're trying to, if there's a boat with people that are in a wavy ocean and you're trying to film them and you can't, and then you attach the camera to the boat itself, right? And now it's moving with the people. Is that kind of the idea?
Great analogy.
Camera that's
Yeah, it's probably sort of like an iPad strapped onto somebody's chest. There's basically a lot of motion artifact in the image. Yeah.
That feels very present for me somehow. I'm not sure.
All right, let's go into this room over here. So in order to image the brain or the heart or any other organ, we need to gain access to the organ, like optical access. So we need to perform surgeries on the mice. And this is basically we have here 3 different setups. And in all these setups, we can perform those surgeries. So these are stereoscopes to look at the mice because they're very tiny. And so we need to perform microsurgery on them in order to put a window, a glass window on the brain or on the heart or on the kidney or whenever we want to image, and then put the mice in the microscope. So this is where all that happens.
Nancy, do you have a mouse for the craniotomy available?
I don't know. Should we get a mouse?
No, exactly.
Yeah, he is recovering from surgery. So. This is a heating pad to provide heat, and he has water and food available.
Mike, you probably noticed that those mice have been had time to recover from the surgery, and they don't look quite as slow and those kinds of things. They recover from that very well and run around for months with that window that allows us to follow the progression of Alzheimer's disease in their brain.
Are you going to show any of the offices?
I don't know. Did I?
Office.
There's some people working here, but
Like all the people say hi.
That concludes the second installment of the Schaffer-Nishimura lab tour. In the next and final video, we get to take a look at the huge microscopes where they collect the images of the vessels themselves. More resources about stall catchers and other projects here at HCI are linked in the description below. Don't forget to like and subscribe, and thank you for watching. We'll see you next time.